Hello everyone. In this video, we're going to talk about an important topic in ROS2, which is called actions. We're going to create an ROS2 action client, which will rotate the turtle sim by 180 degrees. In this process, we'll learn how to create an action client using C++ and in ROS2. So let's dive deep into it. So to understand actions a little bit better, this is an illustration in ROS2 website. You can see that this is an action client and this is the action server. So it's basically composed of client and servers, and subscriber and publisher. Two servers, one publisher, two clients, one subscriber. That's all which makes this whole action. And that's what it makes it so powerful, is because you get a constant feedback, unlike in services and in publisher subscriber model. So you can see that first you send what you need, the goal, and then this receives it, and then it says, okay, I received the goal. And once that's done, then you ask for the result. But the result takes time, and when it's processing, this publisher keeps publishing. Okay, I'm going towards this. I'm going so much value towards the goal, and then so much, and then it just keeps publishing, and then the feedback constantly receives what the feedback of how it's trying to achieve this goal. Once that is all completed, this sends the response, and then this is done. This is how a complete action client talks to an action server. So when you have turtlesim node running, where you have ROS2 run turtlesim node, you can see what are the different types of actions which are there. So if you give a ROS2 action dash t, it will tell you what is the different types of actions which are running and what type it is. So here you can see that it's turtlesim action rotate absolute. So once you know the type, you want to know how the structure of this action is. Like, how do you communicate? What are the data you send? What it sends? That's that structure. If you want to know that, you give ROS2 interface show and the type. And this is true for say message types or service messages type or action messages. ROS2 interface show and the type. So if you give this, then you can see that there is theta, which is what angle you want it to go to, and then the delta, which is how much it changed, and then the remaining. So it's divided into, this is the goal, this is the result, and this is the feedback. Just like any other package, here we have the client package created, and inside that it has a launch file, source code, CMake list, and package XML. Inside the source code, we have a C++ code here. As usual, we include basic header files, and then after that, we include header files such as the rotate absolute, which we use for rotating the turtle sim, and then RCL CPP, and then RCL CPP action. This is something which is specific to anything related to actions which we do. Here we're doing an action client. So next we create a class called turtle action client, and then in that what we do is we define alias names, which is for this type, which is turtle sim action rotate absolute, and also the same thing we do for gold handle, which is RCL CPP action gold handle, and then the type. After that, we do an explicit constructor definition, where we kind of initialize all the node here. We are doing the initializing the node, which we are saying the name of the node is turtle action client, and then we are also initializing the goal done as false. Go down then we initialize this pointer for the client. How we do that is we use RCL CPP action, create client, and then type, which we defined before. And then we do all of these, which is specific to action. It's like a template where we do all these things when we are creating this client. Basically, all these give an interface to the node, an interface to the graph interface, logging, waitables, and so on. And then we give the name of the action server, which the client will be talking to. After that, we define this timer. Here we use the timer to like constantly establish a service to the action service. Here we give it as 500 milliseconds and we bind it to this send goal. This function is basically to see whether the goal is done or not. If we go down, this is the function which is being called back by the timer. What this does is that it checks whether the client pointer has been initialized or if the client has connected to these to the action server. It gives like about 10 seconds, and if it still doesn't connect, it says there's an error. So assuming all the connections are good within 10 seconds, what happens next is that we initialize this goal message to this type, the rotate and goal. This is the goals part of it. And then we define the theta inside the goal message. So for it's divided into three sections, which is the goal, the result, and the feedback. So here we are defining the goal section. We are saying it to rotate 3.14, which is pi, 180 degrees. So if you go down, we say that we are going to send the goal. And before we do that, we also define this send goal options. The send goal options has some definitions where we can where we can initialize the callbacks for response, for feedback, and result. So any of the action is composed of a response, feedback, and result. So here we set the callback when it's a response, and we say that we bind it to the goal response. And the same way we do it for the feedback, and we define this as the callback function. And similarly, we do it for the goal for the result, and then we set this as the callback function. Once all of that is done, we define this goal handle future. This is the one which receives the future class with the action. So if you see here, we take the client pointer we created in this class, and then we ask the async send goal. It's similar to the client in the service. And then we define the goal, and also we set the send goal options. The send goal options, which has connections to what callback it has to do based on whether it's a goal, feedback, or a result. Next off, in the private section, we initialize all these variables. We put the type and the name. As you can see here, we define the client pointer, timer, and the goal done. And then we define all the callback functions. Here the callback functions are goal response callback, feedback callback, and result callback. For the goal response callback, we create this pointer and we name it as goal handle. And then we see if we received any goal. So if we have something on the goal handle, then we receive something. So goal was accepted. If we don't have, then the goal was rejected by the server. Similarly, for feedback, we do the same thing. We create this pointer, and so we get this pointer and we point it to, we call it as feedback, and then we constantly log the feedback. We say that feedback remaining angle is feedback, and that pointing to the remaining, this is one of the variables in this action message. And the same way we do it for result, but there's one small difference here. We don't use a pointer but we use this wrapped result, and then we reference it to this result. So based on this result dot code, so basically when it succeeds or aborted or cancelled, it gets some code, and then we use that in a case to see what happened. And so if it's aborted, you say it's aborted, cancel, cancel, and then the default would be unknown result if none of these is true. Um, and then we log what result we received. So we do result received and result dot result and delta. This is kind of different from this one because here we feedback is a pointer, but here result is not an actually a pointer. It's from this wrapped result, and then inside that we take result, and then that's a pointer, and then we get the value of delta. So that's how it's slightly different from the feedback and goal. Once we have done with the class, we define the main function. Basically, we initialize the RCL CPP, and then we initialize action client. One thing different from client which we used for services is that here we initialize a multi-threaded executor, and then we add this action client to the multi-threaded executor, so that we can run parallel threads and it's not like a single thread execution. And then we say that as long as the goal we don't get any this is goal done is true, as long as it's not true, you just keep running this whole executable. And then once it's done, you shut it down and return 0. So that's it. With this, we have written the code in C++ to move the turtle by 180 degrees, just rotate it. And with regards to the CMake list, make sure that we have the RCL CPP action, and then turtlesim. And then similar to how we have defined in the previous videos, we also have add executable, install, and install target, install directory. And add executables, we make sure that what we have is converted to an executable named action client node. And then in amend target dependencies here, we make sure whatever the dependencies are mentioned here. And then we ensure that we give in the path in the install. We add these things in the install directory. So we add the node and then also the launch file. Package XML, make sure to have all these dependencies here. With regards to the launch file, it's how we do it for any other node. So we define the package name, we define the executable name and output area. So that's it. This is how we make this action client package. So first what we do is we run the turtlesim. So we can have this over here. And once that's done, what we do next is that we go to the workspace and then we do callcon build. So once callcon build is done, we do source install, and then we do ROS2 launch act client, and we do action client launch. And you can see here that it's rotating sharply 180 degrees. So that's it. That's how you can create a ROS2 action client to command whatever positions you need, and for different types of packages, different types of action nodes would be available. Some common examples are like joint trajectory controller and move it controller, and most of it works on actions. So learning actions is a very important thing in ROS2, and this video would have equipped you with enough skills to explore the different types of actions and implement uh, more easier ways in your project. Um, Thanks for watching and follow to get weekly robotics content.